So you're like, what happened to 5.1, Mr. Dirksen? 5.1 in the book is kind of just exploring probabilities and odds. So we jump right into just working with probability and odds. Okay. Have a calculator ready as well. Probability is the likelihood of an event happening. It can be stated in 4 ways. Okay, you can state it as a fraction. That's the most popular one. And watch, every time I ask you, if you state it as a fraction, before you branch off to the other 3, we can do the words already. 1 out of 3. That one is easy to do. 1 out of 3. I want you to do this. So you would go 1 divided by 3, right? So you want to imagine that you're going to write down what your calculator shows here. Okay? And if you state it as a decimal, it would be 0.33 rounded to 2 decimals. If you write it as a percentage, a lot of students want to go straight from this answer to here and say that's 33%. You go back to this. If you want on your calculator, you multiply that by 100, and it's 33.33%. Okay? So you always want to go back to this is what your calculator is showing. Okay? Your calculator showing this. So as a decimal, you would write it like that. As a percentage, you write it like that. What I often do is I just state my decimals in 4. Like I round my answers, my decimal answers to 4. And then I multiply that by 100 to get this. Then you get it right every time. Okay. What about 3/4? You all know that one. That's 0.75. So obviously that's because it's a finite decimal, then that's just what it is. And you go back to that, you multiply that by 100, right? How about we do the middle arrow? Just multiply it by 100, you get 75%. And this would be 75 out of 100 in words. Words are very far and few in between. I'm not going to be too keen on that, but here we go. The next very important concept is that the probability of an event happening and the probability of the event not happening, right? So remember the little mark like this or the bar across means not, right? Remember that from chapter 3. That always has to add up to 100% or 1. Okay? Therefore, if there's a 4 in 5 chance of it raining, we know that there's a 1 in 5 chance of it not raining. Okay? That's very important. So if probability of rain is 4 out of 5, probability of it not raining is 1 out of 5. If probability of rain is 0.8, what's the probability of it not raining? Oh, sorry guys, the bar didn't make it here. It'd be 0.2, right? You make sure they add up to 1, or that the fraction ends up being 5 out of 5 in this case. Probability of rain is 80, probability of it not raining is 20%. So every single time, if you think about it, right, this plus this plus this is 5 out of 5, which is 1. Check, right? Rain and not rain, if you add those up, you get 1. Check, right? If you add 80% and 20%, that's 100%, which is really 1, right? Check. So very important. I don't know. I think it's just a slam dunk, but a lot of students forget that. Okay, so make sure you don't. In general, the probability of an event happening is we use this very simple formula that you've used many times, and I hope in elementary you did probabilities already there, right? Is number of favorable outcomes. So what are the outcomes of this happening? Like hearts. How many hearts are there? 13, right? Total possible would be 52, right? So it's very basic. An event is a collection of favorable outcomes that satisfy a specific condition. Remember this, the sample space or the universal set, notice that I have them together, is the total possible outcomes of an event, both favorable and not favorable. Okay? The complement of an event is denoted as A with a little tick or a bar and represents the outcomes that don't satisfy the condition. So maybe complement is like this and do not satisfy the condition, but are part of the sample space. Right? They're still part of your sample space. So in general, the probability of an event happening is number of events that fall into that category over the universal. If you want the probability of the event not happening, then obviously you take the not and put it over the universal. Also, since PA, probability of A happening, and probability of A not happening is equal to 1, we can also say that, right? Probability of something happening is 1 minus probability of it not happening. I will add this one here, or probability of not happening is 1 minus probability of it happening. Okay, so it's the same thing. By the way, folks, 1 is 100% in probability. That is your universal set. Remember, probability of something not happening, you just take the universal minus it happening. Remember from chapter 3? It's the same concept. Same concept. Okay. Note, if a question asks for the probability of an event occurring, you should immediately try to come up with a fraction where the denominator is greater than the numerator. Guys, everything is based on what I've seen. The notes are based on what I've seen students get wrong. You need to make sure your denominator is greater, and you'll see later on that it's easy to catch, right? Then you know you're wrong. You need to change something in your calculations. A fair game has a probability of winning of 50%. A 0 chance is impossible, while 100% is certain, right? So if you have a 40 or a 30% chance of winning a game, it's not considered fair, right? Because most of the time the person running the game is going to win, right? 50% is considered a fair game. That's probably worth highlighting. The other one, you know, right? 0 is impossible, 100 is certain. No news there. Okay, next page. I want to build this so we can start actually calculating. What is this? Okay. I think I'm going to just kind of fly through it today and then come back to it later. Do you remember talking about experimental probability versus theoretical probability? Anybody? Yeah. What's the biggest difference between experimental and theoretical probability? One is what actually happens, like after you're performing tests, and theoretical is what should happen. Yeah. So for example, if I told you that drawing an ace in theory is what? How many aces are there? 4 out of 52, right? In theory. But do you think that if I draw 52 cards that I will have drawn like randomly, right? That I will actually have gotten 4? If I go 52 draws, will I get 4? Not really. The problem is you need to perform a lot of experiments. You need to like draw maybe 100 to maybe 200-300 draws until you start seeing that pattern. Okay, and so theoretical is based on a large sample size. Okay, experimental is so they should be close to the same if you perform enough experiments. Okay. So the probability of the event A occurring based on trials. I'll say this, based on trials. Okay? And so the formula, even though it looks the same, the principle is still remains intact, right? So NA is the number of favorable outcomes, and T is the number of total trials. or experiments. Example, likelihood of someone having a certain blood type, that's based on experimental probability. Likelihood of a team winning a game, right? When two teams meet, they have odds of winning. That's all based on actual games, right? We call that trials. Versus theoretical probability, if you're dealing with theoretical, oh, I made a mistake because I did copy paste, right? This is the exact, so the probability of that event occurring based on, so not trials, cancel that. What should happen? Just put should happen here. Should happen. Just add that there and then we'll leave the rest as is. So notice that it's the number of favorable outcomes over the universal. And the universal set is determined by, right, how many cards are there? How many sides does that die have? Right, it's determined, like we can figure that out. So number of possible outcomes here. And U is the number of possible outcomes. Likelihood of someone drawing an ace from a deck, likelihood of rolling a 5. Okay. In general, when we perform experiments involving events where there's no bias, the experimental probability should be similar to the theoretical probability. The main reason that they may be different is because of a small sample space. Okay, they're different when there's a small sample space, meaning you haven't performed enough experiments or trials. An example could be that someone flips a coin 4 times and it lands on tails 3 times, right? The experimental probability would be 3/4, right, for tails, but the theoretical probability clearly states that it's 1 in 2 chances of it landing on tails, right? The sample space is very small, right? Only 4 trials. Performing 100 or more trials would result in theoretical probability being equal to experimental probability, or similar, very similar or equal to. I just decided to throw this slide in there because there is a difference between the two. Okay. I think the main idea here is the sample space, the number of trials makes the difference. Okay. Okay, let's move on to some practice here. I feel like most of these you will be able to fill out yourselves. Okay. State the probability of the following as a percentage when rolling a 6-sided die. I will actually tell you to do it in at least 3 forms. So fraction, decimal, percent. Okay. So probability of a 2 is just 1 in 6. Then you go comma. Watch how I'm going to do this. 1 divided by 6. So I will write down 0.1667, right, comma, and then I just shift the decimal 2 places because you're multiplying that by 100. So that's 16.67%. I want you to do that for all of them, okay? I will do my attendance. Try to fill this in yourselves. I'm very, very confident, guys, that you can do most of them, if not all. And I'll do. you haven't seen it, if you go 4 divided by 52 and you go math fraction, it turns it into a simplified fraction. Ace of club. There's only one ace of club, right? How would you interpret greater than 6? So would you go 7, 8, 9, 10, Jack, Queen, okay. There is a 10. I remember I reversed my notes, remember? I did tell you 9 and then, sorry, Avril corrected me. There's actually a 10. That was my bad. So there's 7. So 7 times 4, right? 28 cards. So it'd be 28 over 52. 14 over 26. 7 over 13. Five, 385, 53.85. I'll tell you, I had to Google that too to make sure that I got it right. There's a 10. Yeah. No, I want you to truncate it. Yeah. A red queen. How many red queens? One over 26. That's 0.0385, which is 3.85%. Red, you can go one half, right away. Half of the cards are. It's too crowded. I should have given you more space. Sorry, guys. Not face cards. The not, right? I would do this. I would go 52 minus 12 over 52. Okay? So it's 40 over 52. That's how I want you to look at. So I split it in half, right? If you're not, keep splitting in half if they're even till you get to this point, right? At 0.7692, which is 76.92%. Picking a jack, there's 4 out of 52. I'm pretty sure I did that earlier. There's a 4 out of 52 way up there, the ace, right? So that's 113. I'm just going to copy that. Make sure you get the 0 in there. Probability of not getting a jack, I would go 52 minus the 4 jacks, right, over 52. So that's 48 over 52. I'm pretty sure there's a 48 out of 52. No? Okay. So that'd be 24 over 26, 12 over 13. That's 0.9231 or 92.31%. Red face card, 12 in total. Half of them are red, right? So 6 out of 52. Split both of them in half. And you got yourself it's 0.1154, which is 11.54. If you round your decimals to 4, you will never lose marks. The rule is minimum 2, but you can do more if you want. So you might as well just round it to 4 and then just multiply that by 100, and then you always have it all. That's how my keys will be quite often. Any complaints about this? We're good? Okay, let's keep going. So this is probability. And now we're going to do odds. Odds. Probability and odds are related, but they're not the same. Okay. When we deal with odds, it is important to remember that there is no universal, guys. No total. No total. When stating odds, we use, right, colon, where we can compare favorable to unfavorable outcomes. It happening, it not happening, right? Event happening, not happening. In general, odds in favor. So that's where it gets a little tricky. There's odds in favor, and there will be times where it says odds against. Watch out for words like this. That's why I give you various different forms, like favorable, not favorable, or you can say for, against, or you can say number of outcomes where it does happen and it doesn't happen. Oops, that should be and there. And not happening, okay? The number of outcomes where it does not happen. When the question says odds against, it flips everything. Watch this, right? Favorable goes on the right side and not favorable are on the left. So against 4, against 4, against 4. So the word against, if it says the odds against the Jets winning, that means that winning would be on this side of your odd, of the odds that you're going to state. Remember to reduce all fractions and ratios. I think it would be a good skill to have before you graduate to be able to simplify fractions. So I'm not going to mark it wrong, but I would encourage it if it's because technically in grade 12 applied, that's not an outcome that we're supposed to test, right? Note, get the total sample space, right? The sample space or the universal, right? To get that, we add, right? We would add both of them together. So if you see your odds like this, it doesn't matter if it's against or if it's stated for. To get the universal, we would add those two up, okay? Which is important to get your probability from that. So notice, converting odds to probability. Watch this. This is study sheet entry probably. Odds for, if it's saying odds for, then this is in favor and this is against. If you're supposed to write the probability of A happening, how about we use different highlighters here? We will make this pink and we will make this green. And the total, I'm going to use orange. The total, I'm going to go like this. Okay. So notice that in both cases, in both cases, when you're stating the probability, what's the first thing you should be doing? You should add both numbers in your of the odds. You should add it and put it in the denominator immediately. And then you have to very carefully understand which one is which. If it's saying odds for something happening, and this is obviously the first number is it happening, so then let's get my highlighters right. And you would state it like this, right? If it's once the probability of it not happening, you need to grab that second number and plug it here. You're going to be sick and tired of too many charts, okay? I could have added another chart where it said odds against, in which case this would have been flipped like this, right? So you got to watch out. You got to know which one is which and then put them in the right place, okay? You with me or what? I hope you are. And notice something else. Remember, always probability of something happening and not happening. Why is this bracket with a 1 there? Because if you do this right and add these probabilities up, you should still always get 1, okay? Or 100%, or 5 out of 5, or 7 out of 7. Whatever the fraction is, it'll be 1, okay? Okay, let's do some math here. I don't know, guys. That's something I've learned. Highlighters, in my opinion, when you come back to study this later, you're like, oh yeah, oh yeah, oh yeah, right? Like you see everything. It just comes to life, okay? So here, the odds of the Jets winning the Stanley Cup is 1 to 6,000, while the Avalanche's odds against winning the Cup are 400 to 3. Who has a better chance of winning? Show your work. Which team, I should say, right? Which team has a better chance of winning? Show your work. And I really wanted this to be mixed up, just like really mixed up, so you really understand what's happening. So let's go with the Jets first. Okay? And I'm going to highlight what kind of odds, because there's odds for and odds against. What kind of odds are we talking about? Notice that it says the odds of winning. Odds of winning, which means for. Odds of is the same thing as for winning, which means that the first number represents win, right? And what does that second number represent? You're going to say losing, right? I'm going to say not winning. Are you okay with that? It's the same thing. So go win with a little bar on top, not. The way it's written, what preceded this, the odds here, this is what tells you which one is which. So we're going to go win, not winning, because remember that's what odds are, would be 1 to 6,000. That's what we were told. Okay. So how would you write the probability of winning? What's the first thing I want you to do? Add them up. Add these numbers up and put them in the denominator. That's your total. You got your total there. Out of 6,001 games or chances, how many wins will there be? Just one. So what did I do earlier? Pink, right? Pink, pink, orange. I should get a commission from highlighting companies, right? Sharpie, I'm going to send them an email. Probability of winning is 1 over 6,001. Let's write that as a decimal because quite often a fraction is not going to help you determine. Why am I turning this into a probability? Because when this asking you who has a better chance, you need to turn it into a probability. So, oh, what's happening there? You see that scientific notation? If that happens, I'm going to just turn that into a percentage because it's too small. So I'm going to go times 100. Should I put this down here? I will just go 0.017% of winning the Stanley Cup. So it's not looking too good, is it? Okay. Too small to write as decimal, right? Too small to write as a decimal. And you're going to say, too small to read, Mr. Dirksen. I get it, right? Too small to write as a decimal, right? So you're like, this is a decimal. No, if it has a percent symbol at the end, we call them percentages, okay? So that means that I turned this into a decimal, then multiplied it by 100 to get this. Let's talk about the avalanche. Okay, what happened there? How was that stated? So you see that it's odds, right? But you need to go back. Like how did they write it? Odds against winning. Let's underline against. Okay, that means that it's not winning and winning because of this, right? So that means that the 400 represents them not winning and the 3 represents them winning. We're going to leave it like that and say, hey, we want to know, because we want to compare it with the Jets. Probability of winning, what's the first thing I want you to do? Add them. $403. Should I do 400 plus 3? I think I will do that. You choose what you want to do, right? And then at the top, this is the win, right? This is what you want here. Right? That's the one you want it. So that's really probability of winning is 3 over 403. Let's turn that into a decimal. It's better, right? It's better. We can handle that. 0.0074 times 100, right? You shift the decimal. That's 0.74%. So who has a better chance? It's the avalanche, right? Therefore, I will say this: since avalanche has a greater probability of winning, they have a greater chance. Oh my goodness. Yikes. But that's what it says there, I promise you. Since Avalanche has a greater probability of winning, they have a greater chance of compared to the Jets. Okay? So we were given odds, we turned them both into respective probabilities, and then turning them into percentages or decimals are the way to go. Because fractions right here, unless you're really good with fractions, it's hard to tell just by looking at the fraction, right? So it's here where we make the ultimate comparison. All right, let's go to the next page here. Oh boy, what's this? Another chart, Mr. Dirksen? I'm off the charts today. Converting probability to odds, so going the other way, right? Let's take our highlighters again. So if you're given the probability of something happening, then we know that the top is it happening. So I'm going to use pink for that one. So that comes here. If it's odds 4, right, event happening, then we would put that top number there. And we need to figure out the number of outcomes where that's not going to happen. So what do I do there? I go universal minus A, right? Universal, I take the universal, which remember, this is my universal here. All the possible outcomes minus A. So that's where that goes. And the universal is there. So what's the biggest mistake that I see? I will tell you right off the bat. This is what I see quite often. The chances of it raining is 3 to 5. I mean, maybe don't write this down. I just want to get your brain going right away. What are the odds of it raining tomorrow? There you go, Mr. Durson. I'm done. That's what I see all the time. This is the universal. This is not the events where it's not going to rain. So you need to make sure you take away, right, what you already put down. So out of 5 times, guys, it's going to rain 3 times and it's not going to rain 2 times, right? That's what odds they compare happening, not happening, not happening and universal. That's not what we do here. Okay, so let's keep going. Our ultimate goal is to find not happening, and that's where subtraction, that's how you get that. Okay, the Bombers have a 45% chance of winning the Grey Cup, while the Edmonton Elks have a 7/9, so 7 out of 9 chance of not winning the cup. Write both probabilities as odds for and against winning. What's happening here? So we're going to do odds for, okay, that's going to be like our A, and then we're going to go odds against, that's going to be our B part. We're going to answer that separately. Okay, so let's do Bombers first. So based on the way you read it, Bombers have a 45% chance of winning. I'm going to highlight that because it's important. Chance of winning. Okay, so that's telling you that the probability of winning is 45%, right? Can we say 45 over 100? I think you should be okay with that, right? 45%. I'm going to write it as a fraction right away. Why would you do that, Mr. Dixon? Well, it's just maybe it'll make it easier because this looks like a fraction now. So odds for winning or of winning, the same thing. What would you do there? We would take the 45 because that's the number of wins based on the probability. That's the win. Okay. Hold it, timeout. You know what I'm going to do here? I didn't do this in my notes, but if the probability of winning is 45%, what's the probability of not winning? 55, right? So I want you to see that there's always the not, right? So in this case, if you just base it on this, you would go 45, and then you would go 100 minus 45, right? So what that would be 45 to 55, right? Winning, not winning. What about odds against? This is easy, actually. Super easy. Just flip this. Just flip it. You'll go 55 to 45. Odds against would be 55 to 45. I'm just going to leave it like that. So how about the alks? You figure it out. Try it. Yeah, I did word it. I worded so that it's very confusing. Like to agree, you have to really be careful what's happening, right? The chance of not winning the cup, 7/9 of not winning. Okay. So that means that the probability is a not win, right? 7/9, meaning that 2 out of 9 it is winning. So odds of winning, if I don't use this one, if we're just given that the 7 represents not winning, right? So that needs to go over here and your odds. And then the winning would be calculated by going universal minus not winning, right? And then always check, do these two add up to the denominator in my probability, and then you know you're doing things right. Probably odds against winning is 7 to 2. You just flip this around. Okay. So maybe what I will do is if it says odds of winning, it's asking for the wins on the left and the not winning on the right. Okay. If it's odds against winning, then you want to almost put the wins on the right and the not winning on the left. So that's why the words for and against, right? Even probability for and against or of and against, important to keep your terminology in place there. Okay, so I want you to, the rest of today's class, just keep working through all those examples there that I have. And the homework is bottom of page 8. Okay, guaranteed an AC tomorrow on this. Guaranteed. So keep working. What I can do is I can scan the answers to this. So I'll scan this and you can check later on if you got it right. I actually have to work these out because my original is different than this. And that's everything for today.